Hello everyone. Hope you all are doing great and safe at your end. Welcome to the day 5 of pre-hackathon speaker session. The Python week is hosting live workshop, talks, discussion, and of course an amazing virtual hackathon. Everything which has already started on 1st Jan and end on 10th Jan. Moving on the speaker session for today. The topic is a live intro to PyTest and how to use the PyTest framework. By the end of the session, you will be able to write your own test to protect your code. And with that, let me introduce you all to our speaker for the session. We have Andrew Knight joining us. Hey, Andrew.
Hello.
Hey.
Thank you, Manav.
He is a lead software engineer at Taste and Precision Ladder. We welcome you, Andrew, and we are looking forward to your talk. The virtual stage is all yours.
Great. Thank you. Thank you. So hello, everyone. As Manav said, my name is Andrew Knight. You may know me as Pandy or as the Automation Panda. I'm a software engineer in test. That means I build solutions to testing problems. And I particularly love to build those solutions with Python, which is my favorite language. So I'll share my screen in just a moment here, but to set the stage for what we're going to do in this talk, we are going to have a live coding introduction to the PyTest test framework. I don't have slides. This is all going to be fingers at the keyboard, showing the terminal, showing VS Code as my editor, and we're going to walk through how to use PyTest to write tests. Testing is very important, right? We don't want our code to have bugs. We want to provide feedback as we go about our development so that we know where problems are and what we're doing well. And if there are any problems that come up, that we catch them right away. So just a little bit of information about myself. Let me share the screen here. Share screen. Okay, there we go. Cool. So if you want to catch up with me after the conference or check out some more of my material, you can go to automationpanda.com. This is my personal blog. I've got a ton of info out there, including stuff about PyTest. If you want to learn about PyTest specifically, you can go to pytest.org. They have wonderful, wonderful docs. And also, if you want to check out the code that I'll be sharing in this live session, you can go to my GitHub. It's AndyLPK247. And the repository that has the code is TAU Intro to PyTest. And you can go under there. You want to look for the example develop branch. One more thing I should mention. There's a website called Test Automation University. It has free courses about testing and automation. You sign up with your account, you get points and certificates and all that kind of stuff. And there are courses on just about everything you could imagine regarding testing and automation. And I've put a couple courses out here myself on Python. So let's start using PyTest. I've got my terminal open here. And so first, of course, you have to have Python. Right now, I'm on Python 3.8. I'm using a Mac. It's always good to have the latest version of Python on there. I think, I don't have 3.9 quite yet, but yeah, it's good enough. Also, I have PyTest itself installed. If you don't have it, you can install it with pip. Pip install PyTest. I believe I'm on version 6. Yep, version 6.2.1. So we're ready to go. To get started with PyTest, that's all we really need. We just need Python and the PyTest package. We could get other packages as we go along the way, depending on what you're trying to test. But to start off, we're just going to use the PyTest framework and write some very, very basic test cases to show how it works before we move on to showing how to do unit testing. And hopefully we'll have time for some integration testing too. So what I'm going to do is I'm going to create a new project. Here, Python PyTest. Now, whenever you start writing tests, you have one very big question to answer. Do you want to create a new project to put those test cases in, or do you want to put them into an existing project? Because we're just starting fresh here in this talk, I'm going to create a new project separate. But a lot of times you probably want to put your test cases in an existing project, specifically the project that those tests are going to cover. Unit tests should always go together with the code that they test. The only time you might want to put your tests in a separate project is if you're doing some sort of integration or end-to-end level test. And perhaps maybe you have an entire separate test team that is developing the test automation. That might be the only case you want to put it in a separate repository. But anyway, we're going to put it in our own project because we're just doing this here as a little tutorial. Furthermore, in Python, it is conventional that within whatever project we put our tests, we put them in a subdirectory named tests. Oops. That just makes it easier to find all of the test cases that we want to run rather than have them sprinkled across the repository or the project, have them all in one place. So in my project directory, I've created a tests directory. And now I'm going to switch over to Visual Studio Code and open that directory so we can start programming. Oh, where is it? Please pardon me if I seem a little bit slow. I'm in Raleigh, North Carolina, and right now it's 6:30 a.m. here. So I know y'all are just about ready for dinner, I'm sure, but oh shoot, I stopped sharing. My bad. But I'm just getting started with my day. Sorry about that little. Okay, we're back. Okay, good. And let me increase the font size here. Let's be too tiny. All right. So inside of our tests directory, I'm going to create a new Python module. I'm going to call it test_math.py. So in pytest, by convention, a test module is prefixed with test_. It doesn't have to be, and you can override that setting with some configuration, but by default, anything that you put in a test_ Python module will be discoverable by pytest. Like I said, we put them under our tests directory. And pardon me. Another thing is the tests folder does not need an init.py file. We do not necessarily want this to be a package. PyTest will discover all the test cases without it. Okay. So very first test case here. We're going to do some basic math tests. And with PyTest, how we write test cases is with functions. If you use unit tests or other frameworks, you might have to use a class. But I really like PyTest because all tests are functions, which is much simpler in my opinion. You always start your test case name with test_. This makes it discoverable as a test case within your test module. You could have other functions in here that are not test cases. By default, PyTest will look for anything that begins with test_ and treat it as a test case when it does its discovery. So we're going to do a very simple test. Test 1 + 1. Pardon me. The body of our test method here is going to be very simple. Assert 1 + 1 = 2. One-line test. Beautiful. What's going on here? Assert is part of Python's language. It is a command. What it will do is it will take in a Boolean condition, and if that Boolean condition is true, it'll keep moving forward with execution. However, if this Boolean condition is false, it will raise an assertion error, which is an exception. Anytime an exception is raised within a PyTest test, the PyTest framework will capture that exception, report it out, do any cleanup, and move on to the next test without any harm. And so here we go. In one line we have, or in 2 lines, I should say, we have our very first PyTest test case. Beautiful. So to run this test case, I'm going to drop to the terminal. I'm in my project directory, and I always recommend running pytest from the root level of your project directory. Discover from the top. And the command to run pytest will be python -m for module pytest. From this directory, it will discover all available tests going down. That's why we have the names with test underscore, test underscore. You could alternatively run just with the pytest script. However, I don't recommend that because it won't affix the current directory to the Python library path. So you might get some errors. So let's run it. Boom. So we've got the test session starting. We've got some top matter here, just about the platform, different plugins available for pytest. I do have a bit more installed in my environment than just pytest. It'll show all the number of tests it collected, one item, and then it will print them out by test module. So here we have one test module, tests/test.math. Every time a test passes, the console will print a green dot. That's a good thing. So if you have lots of tests, you'll see hopefully see lots of green dots off the page. Here, there's only one test, so 100% of the tests were run within this module. One test passed in 0.06 seconds. Awesome. So congratulations, y'all. We've just done our first test using pytest, and it works because I would hope that 1 + 1 is 2. Okay, so what happens though when a test fails? Right? It's great when tests are passing, but the strength of the test framework is going to be when a test fails. And what information does it show us? How quickly will we be able to resolve that failure? So let's write another test case. Test 1 + 2. This time I'm going to write my test a little bit differently. I'm going to be a little bit more verbose about this, and we'll see why. So instead of just shoving numbers into an assert statement, I'm going to write variables out. A = 1, B = 2, and I'm going to deliberately put a bad number in here, C = 0. Assert A + B = C. We'll see what happens. So let's go back to my terminal. If I run this now, again, same command, should discover both tests. Boom! So we see the same banner before. We see the green dot for the first test that passed, but then we see this big red F. Our test failed. So what's going wrong here? Well, pytest is nice because it prints out a banner of failures. And depending on your terminal, we'll give color coding to everything too. So each test case will have the reason for its failure printed out. We have the code of the test case printed. Usually it prints like 4 or 5 lines of the test case, not the entire code, just enough to give context. And it will point to the line that had the problem. So you'll notice this is where the failure happened. Assert A + B = C because this was a false assertion. But what's really, really nice about pytest is notice the next line in red. It does an introspection. It shows the actual value substituted in for these variables. Because if you just were to read A + B = C, you might be like, okay, well, that's the line that failed, but what does that actually mean? Why did it fail? Because you may not have these numbers right here above you. Some test cases I've worked on could be like, dozens of lines long. pytest will give you that introspection. It'll say, hey, it was, A was 1, B was 2, C was 0. And so when you see this assert statement printed out, it'll be very obvious. Oh, duh. 1 + 2 isn't 0. That's why it failed. You'll also see a printout of the line of the failure. It was in testmath.py, line 10, and what type of error it was. Here it was an assertion error. PyTest, like we said, uses Python's basic assert statement. It doesn't need a fancy library or any sort of fancy exceptions or anything. But if your test were to raise a different kind of exception, you would know what kind of exception that was because it printed out here. PyTest also gives a short test summary where it'll print out the name of every, oops, I do not want App Store. Oh my gosh, sorry. Where it prints out the name of every failed test case, and it gives it by the path as well as the name of the test function, as well as the introspected assertion statement that failed. So here now we have the summary, one failed, one passed. So that is how PyTest will teach us, or will show us what fails. Lovely, lovely. Okay. So let's fix this test. We know 1 plus 2 should be 3. And rerun it, and everything should be working. Nice. There we go. So we're passing now. Good, good, good. Now, as I said for the previous test, any sort of exception will make a test case fail, right? So if I have, array index out of bounds, or I have, some custom exception that's in my product under test that's being raised, then okay, cool, great, that'll make PyTest fail. But what if we want to verify that an exception was successfully raised? What if I want to call a function or a method that should raise an exception, and I want to verify that that exception happens? PyTest has a way to do this, which is really nice. So let's test that by, or let's show that by doing a divide by zero test. Test divide by zero. So we know if we do division by zero in Python, we will get a zero division error. If we want to see what that looks like, I can just write a divide by zero statement here and then run the PyTest test, and it should show me exactly that exception. So we know if we just do this, yeah, it successfully raised this, but it still fails the test. And this is the exception type. So what I want to do is I want to capture that exception. You could try to do something like this. Try num except pass, and here assert false. But this is really, really clunky. This will get the job done. Try to do divide by zero, and if you were successful, meaning you got to the next line, you assert false because it should fail. If you get the exception that it should be passing, this will work, but is not very helpful. So that's okay, but there's a better way. What we want to do is use something called pytest.raises. So first I need to import the pytest module. Now what I can do is, in my test function, I can say with pytest raises, and then the exception type, zero division error. Now, what this will do is it will wrap this statement, and if it throws this exception, it will pass, and if it does not throw this type of exception, it will fail the test case. Furthermore, I could capture it and say, with pytest raises this as some object I'm going to save. It'll capture that exception object, and I can make an assertion on the exception object itself. Asserts division by zero is in string value of that exception. This is a much more correct way to check for exceptions. So let's run it. Oops. Make sure this works. Boom, 3 tests pass. Great. Cool, cool, cool. All right, let's do one more basic kind of test case to show the framework in action here. So math operations can be pretty redundant. Let's say I want to test multiplication. There's multiple ways you can test multiplication, right? You can multiply to positive numbers. You can multiply to negative numbers. You can multiply a positive and a negative. You can multiply by 0. So if we were to write these test cases out, I could write something like assert, let's do the positive number case. 2 times 3 equals 6. If I wanted to do another one, I don't know, like 1 times 99 multiplied by 1, anything should be the same. I could do it again. Let's say we want to multiply by 0. Multiply 0 by 99, anything times 0 is itself. We have a bit of a problem here. We're basically duplicating the same thing over and over again. And code duplication is code cancer, right? All of our little problems get spread all over the place. And unfortunately, code duplication is very, very pervasive with test automation because testing does so many of the same operations over and over again. Instead of duplicating our code, we should find ways to try to eliminate that duplication, have shared code. When it comes to different test case values, pytest has a way to do what we call parameterization, where we can have one test case function that essentially has multiple inputs to it. So we don't have to duplicate that same function repeatedly. So let's try that. First of all, we're going to need to create a list of values that we want to test with our function. And each of these values should be a type of input or an equivalence class that represents a unique sort of input. We're going to make a list of products. And there are essentially 3 values that we'll need to pass into our test case. The first one will be the first number for our product. The second one will be the second input. And the third will be the expected answer. This equivalence class represents positive integers. On our test case function, what we can then do is we can pass these as inputs. And we're going to do that by declaring variables in the function signature. And instead of hard coding the numbers in the test function, we're going to use the variables we pass in. So instead of hard coding, A times B should equal the product. Now, finally, what we want to do is we need to tell pytest to take the numbers from this list and shove them into this function. And we're going to use a marker called pytest mark parameterize. First value in the parameterization list is going to be a string that has a comma separated list of the variables we want. A, B, product. And the second value is going to be the list of values, which will be products here. What pytest will do in this case is it will look at this function, see this parameterization mark, and say, okay, I know I need to pass inputs into this pytest function. So these are the names of the variables. This is the list it's coming from. The variable name list should have the same length as the tuples in our data list, and it's going to run the test once for each row in this list of tuples. It's going to do the substitution with dependency injection. First value is going to be A, the second value is going to be B, the third value is going to be the product, and then it's going to run that test with those values. So let's flesh this out with some more values. We can do an identity. We can do a zero property test. We could do negative numbers. We could do two negative numbers. And so each of these 5 rows will be crammed into this test function. Let's see what that looks like. Boom. All tests passed. Now, even though we only had 4 test functions, you'll see that there were 8 items collected and 8 tests run because 5 of those were that multiplication test. I could even do this to make it verbose, and you'll see if you run with the -v option, instead of just showing the dots, it'll actually show a full verbose output of all of the test cases that were run. And so you can see test plus 1 plus 1, 1 plus 2, divide by 0, and then there were 5 multiplication tests. And it even shows the parameter values used. Cool. All right, so that is how we use the PyTest framework. Now you might be thinking, okay, Andy, well, you showed us how PyTest works. That's well and good and all, but these are kind of toy tests. Nobody's going to be testing Python's basic math functions. You would hope that the core developers would be testing those for us. So what would be a more practical kind of test? One in which we would be testing the code that we would be writing ourselves. So let's do that now. Now that we know how PyTest works, we can use it to actually do some more serious testing. And what we're going to do that, we're going to create our own class. It's going to be very, very small. What I'm going to do is I'm going to create a new folder at the top level of this project called Stuff. I'm going to put a init.py module in here to make Stuff a package. And then I'm going to add a module called accum.py. And we're going to create an accumulator class together. Then we're going to test that accumulator class. So the idea of an accumulator is just something that adds up numbers and keeps track. It's essentially a counter. So let's write this. It's a Python class here. Give it an init method. And we'll say it has a counter that initializes to 0. We'll give it a property for the count. So return self.count. What this will do is it will allow us to publicly access count as if it were an attribute, but it won't be able to explicitly set the count attribute. We'll do that internally with this private count. Add self. We'll have an add method that can add more to the internal counter. By default, it'll add 1, but we can override that with custom amounts. A very, very, very simple Python class, but still worth testing because all code should be tested. So now let's create a new test module and call it test_accum.py. Let's write some unit tests for this new class that we had just written together. Okay, so in order to use our new class, we have to import it. Import from stuff.accum import accumulator. So now we can use our class in our test module. We can test classes just like we test anything else. Typically, we want to have at least one test function per method in the class, and sometimes multiple tests per method for different input combinations. So I'm just going to prattle off about 5 different tests here. Test accumulator init. We have to create an object. Accum equals accumulator. Assert the initial count is 0, right? When we initialize this object, we want to make sure that the init method gives it the appropriate starting value. Okay, let's try another one. Def test accumulator. Let's try to add 1 value to the count. So again, let's initialize our accumulator. Accum.add, just call it with the default value. So now we know that assert accum.count should be 1. Because it started at 0, we added 1. Okay, let's try to add 3 instead of just 1. Start with our object, accum.add, and this time we'll provide an override value. Again, assert accum.count equals 3. Alrighty. Let's see what happens now when we call the add multiple times. Def test, accumulator, add twice. So this time, I'm going to call the add method, but I'm going to call it multiple times. We're going to hope that it adds up everything as we expect. Assert count, accum counts 2. And a final test, we'll test that property. Test accumulator cannot set count directly. So for this one, we're going to make sure it doesn't raise an exception. So with pytest, so I need to import pytest as well. With pytest raises, attribute error. I want to make sure I'm going to do a little special trick here. I'm going to make sure that it matches a particular string. Can't set attribute because there could be multiple kinds of attribute errors. I want to make sure I get the right one. And I won't save the exception object this time. We'll just roll with it because we batched it on string. Accumulator. So if we try to set the count directly like this, it should fail. And there we have it. We have 5 basic unit tests for our accumulator class. Now, I call these unit tests because each one is a white box test that covers code, right? We're creating an instance of the accumulator object and exercising its attributes and behaviors, right? We are directly calling that module. You'll notice that each one covers an individual unit of behavior. So things like initialization, adding in different ways, trying to set the counter directly. You'll notice that the names are rather descriptive, right? I should be able to know what the test covers based entirely upon the title. That's why even though this one looks a little bit long, it's almost like it's some sort of Java length name. It's still very helpful because if this were to fail, we would know what failed. Well, the accumulator, we tried to set the count directly and it didn't fail, So, and also these tests are fairly simple, right? There's nothing magical or difficult going on here. Some people are a bit hesitant to start testing because they're afraid that they'll write bad tests. They don't know exactly what level of coverage they should be going for, right? But here you can see we didn't do a whole lot with this test or with this class. We have some just basic tests, and this is probably good enough for unit testing purposes. We can feel confident in the coverage we have, because we're adding in multiple ways. We're checking the bounds of safety. We're making sure it gets started off right. That's all you really need to do with testing. We're trying to testing. You're not trying to cover everything 100%. You're trying to put in a reasonable amount of coverage to mitigate the risk of having failures. So let's give these new tests a run. So I'm going to run pytest from the top of my directory or top of my project again. And what we should see now, great. In addition to the math module, we also ran the accum tests. And so all 5 of them were passing. Great. Now you might be wondering, okay, well, what if I don't want to run the math tests? What if I just want to run the accumulator tests? For this little example, it's not that big of a deal because it only takes a fraction of a second. But when you're working in a test automation project with, let's say, hundreds or maybe thousands of tests, and maybe they're not unit tests. Maybe these are web UI tests that have to open up a browser and do some page navigation each time so that they're very, very slow, right? You may not want to run all of your tests all the time. You may want to slice down. pytest will let you do that. First of all, you could provide a directory path. So I could say test accum. And when you provide the paths, and I think you can provide multiple paths, not sure, but you can give it a try. Anyway, if you provide a path, it'll run only the tests it can discover within that path. So if you provide a folder, it'll look for all the tests in that folder. If you provide a module, it'll look for tests only within that explicit module that you set. And furthermore, you can even provide down to the specific test cases. So if I wanted to say test the add one test case exclusively, you can do : name of the test case, and it should, there we go, run only that one test case. Cool. So let's take a second look at these unit tests. We know they're good. Their coverage is decent. They provide a reflection of the actual behavior of these methods and attributes. But there is one area for improvement here. If you notice, there's a lot of duplicate lines. Every single test case has to create the accumulator objects. And though this here may not seem like that big of a deal because it is a small example, test case setup is a pervasive concern. And pervasively, it has duplicate code, right? Good test framework should have a way to do setup a little bit better. If we were using the unit test framework or other XUnit style frameworks in other languages, we'd have a class, and there'd probably be like a setup method in that class that all test methods use. But pytest doesn't have classes, it has functions. So pytest has a special way of handling that kind of setup. It's what we call fixtures. Fixture is essentially a setup and cleanup function for pytest. And it's way more reusable than setup and cleanup methods in XUnit style frameworks, because fixtures can be used by any test case anywhere. Let's make a fixture together. I want to make a fixture that will construct the accumulator object. I'm going to create a function. I'm going to call it accum. And I'm going to make it return a new accumulator object. Right? So fixtures will return the objects that they set up. To make it a pytest fixture, I affix the pytest fixture decorator. So that way pytest knows this is a special kind of function. This is a fixture function. And anywhere I want to use this fixture, what I'll do is I'll copy the test or the fixture name, and I will declare it as a parameter in the test signature, the test function's signature. This is crazy, right? I can remove this now. And how this will work is that when pytest runs this test case, it will notice that there is this variable in its function signature. And so pytest will think, okay, let me look for any fixtures available that match this name. And since this fixture is in the same module, it'll say, aha, I have an accum fixture. So pytest will automatically call this fixture when it sees this in the test case, and it will inject the return value as this variable into this test. So every time you run a test that declares a fixture, you'll get its return value as an injected input to the test. And so because the default scoping of fixtures is such that every test case will call the fixture fresh. So now I can basically eliminate all this duplicate code. Boom. Boom. So each of these tests will get its own new, fresh accumulator object. Boom. Boom. And we've tidied up the code a lot. Much, much less duplication. But will it work? Yes, it will. Look at that. All tests are still passing. Fixtures are the best way to do setup and cleanup with pytest. You can do amazing things with fixtures. So you can actually have fixtures call fixtures, just the same way that this dependency injection is done. If you wanted to have a cleanup routine, instead of doing a return here, you could say yield. And then after that statement, you could put any cleanup operations you want. Anything after this yield statement will automatically be called after the test case is complete, whether or not it fails. Really, really cool stuff here. Awesome, awesome. So that's how we can do unit testing with pytest. I'd like to do one more test example before we open up for question answer. I'd like to do an integration test with REST APIs. So I'm sure most people are probably familiar with the requests module. It's one of the most popular modules in Python. I already have requests installed, so that's good. We could use the requests module to call a REST API in a test case and then verify parts of its response. So An API I typically like to use for demonstration purposes is the DuckDuckGo Instant Answer API. DuckDuckGo is a search engine like Google or Yahoo or Bing. And it has what they call their Instant Answers API, which will let you, it'll let you search for questions directly via an API rather than having to use a web UI. So if I were to use the Instant Answer API, format is here, api.duckduckgo.com/?q equals, and you can put in a query. So I'll put in Python programming, and I want the format to be JSON that's given back to me. And so, whoa, if you were to put this in a web browser, I know this text is probably very, very small, but you get this gigantic JSON object with all sorts of information in there. What we can do to test a REST API is we can make the call, parse the JSON, and then validate parts of the response. Very, very easy to do with Python and requests. Okay. And I should also say that REST API test automation is very, very, very prevalent within the development space. So let's make a new test module. I'll call it test REST API. Actually, that's probably not a good name. DuckDuckGo API. We never want to say test what the type of product is. We want to say test what the product is. Test DuckDuckGo API. So for this test case, I'm going to need to import requests. We'll say test DuckDuckGo Instant Answer API. So that's what we're doing here. All right. So one final tidbit I'll give for good testing practice. There's a pattern called the arrange, act, assert pattern. It's a pattern for structuring your test cases well and not doing too much within any given test case. 3 parts. Arrange means setup. What do I have to do to prepare for this test? What I need to do really is I need to set up my REST API for being called. So because request is so simple, there's not a whole lot that needs to be set up. But what I can do is I can establish what my URL is. So, right there. The next step is act. Act meaning exercise the behavior. So what I want to do is I want to call requests. Response equals requests.get, meaning I'm doing a REST API get or an HTTP get. And I'm going to use my URL. And then I'm going to get the body from the response JSON format. That does the exercising of the behavior. And then assert means do the verifications for the outcomes of that action. I'm going to assert a few things here. First of all, I want to make sure my response code, status code, is 200, meaning success. And I want to assert that the content actually has what I think it should have. So we'll do just a basic check, not exhaustive. Assert Python in my body in the abstract text section. And so here in 5 lines, we have a full REST API integration test. So PyTest can be used for more than just unit testing. It can also be used for feature level testing, for black box testing. You can test anything, REST APIs, web UIs, mobile apps, command line apps, whatever kind of thing you want to make, you can test with PyTest. All software is fundamentally testable. So let's run that. And we'll just run the, oops, I can't type it. We'll just run that REST API test. That was still pretty fast. DuckDuckGo, API, one dot. You will notice it was slightly slower because I had to go out to the API and over the network and call back. So just note that unit tests will be very fast, but non-unit tests, like feature tests, anything that calls a live instance of something, could potentially be much slower. There you have it, folks. We have our basic test case example project using pytest. As I said before, you can check this source code yourself at github.com/AndyLPK247. That's my personal GitHub account. TAU Intro to PyTest. Make sure you're looking in the example develop branch. You'll see all the test cases that we talked about today here. Furthermore, if you want to get really, really hands-on with this, there is a test automation university course that I've written called Introduction to PyTest that will walk through all of what we talked about today in deep detail. And there are also other test automation university courses on Python, such as automated visual testing with Python or Selenium WebDriver if you want to do web UI. Or there's even one on a PyTest extension called PyTest BDD if you want to do behavior-driven development style tests, given read that. Fantastic. So that is the material I have to share today. So oops. I believe if there's a little bit of time extra, I could take some questions from the crowd. If not, then all good. Oh, Manav, I think you're on mute, buddy. You're still on mute. Oh, no. So while Manav is still on mute, I can take a look in some of the comments and see.
Sorry.
Okay, he's back. Great.
But really, it was indeed a great session and had a lot to learn. Let's now jump on Q&A session. So we have some question in our comment section. The first one is from Nishkal. Pytest.make parameterized. Does this work same as a zip?
I'm not as familiar with Python zip function off the top of my head. I'd have to look at that and reply. You will not be able to use zip in place of pytest mark parameterize. I can tell you that. But I believe zip is basically just like stitching things together in a list, like stitching together two lists into one. So that's going to be a little bit different. The reason why pytest mark parameterize has this string for AB product here is because pytest, for some reason, it needs to have a way to kind of line up exactly what the tuple order is and then to know what the names are. And so the pytest developers decided the easiest way to do that would be, let's just have a string here, and then we'll just shove that in, and then the products list is obviously the whole list of tuples. So
yes,
a little bit different than zip.
Exactly. We have one more question from Jay Patel. Do we need to test the service and controls method separately?
Do we need to test the services and controllers methods separately? So depends on your web architecture, but I would say yeah, right. If you're talking about a bigger web UI product like ASP.NET or something, you're going to have the services, you're going to have controllers over here. They're essentially two different kinds of things addressing two different concerns. So yes, I would say at a unit test level, you should probably test them. The controllers themselves are kind of Cody kind of thing. So you'd want to have unit tests to cover those. If you're talking about then services, meaning like the REST API themselves is an integration test that, again, separate levels there. So, one would be more of a unit test, make sure the parts work. The other one is more, okay, does the service API itself overall work correctly? So, yes.
Exactly. So we have one more question from Sahil. How can we mock data for testing for our API request?
Oh, that's painful. It's a great question, though. It's a fantastic question. When it comes to testing at a black box level, you're testing live instances of things. You can either have the entire system set up and push data through it, or you can try to mock certain things. I find that mocking tends to be a little more hassle than it's worth, and sometimes. So, like, maybe if you've got a service that you're testing that does CRUD operations, create, retrieve, update, delete, you may just want to like create some test data in there and then use that for retrieval and update for testing, rather than try to mock a service. You could try to go behind the scenes to the database and inject data, a little dirty, still possible. You may want to just mock the entire service, kind of make like a dummy service out there in its place, so that you have any dependence. Like there's like one main thing you want to test, and you want to test the live thing of that, but that may have dependencies on other services. So you might want to create some. You can use something like Flask. Just grab the specification of the API, put a bunch of like dummy services out there that literally just return values that don't actually do anything. There's no access to persistence or something. That could be one way you could mock. So yeah, there's
Exactly.
parts of strategy, but
Yes. I think now we don't have any question unanswered. So some of the participants are not live right now, but surely they will have full access to our recording. So guys, later on, if you have any question, feel free to ask in our Discord server. There are one channel, Ask Speaker. You can ask their doubts to our speakers and even Andrew. So I have one question from my side.
sure.
As you know, we will be hosting 48-hour hackathon. Do you have anything you would like to suggest to our hackers?
What would I suggest to hackers? Quality matters. Make sure that you have some sort of feedback loop as you're going along to make sure you're doing the right things. Whether that's taking a step back every once in a while for a breath and say, is this right? Looking at, okay, what is the value we're trying to deliver in what we're doing, rather than wasting effort on useless things. Or whether that feedback loop may be just writing some unit tests as you go to keep yourself safe.
Yes,
Good luck, hackers.
exactly. These are some valuable suggestions. It would be great to help for hackers. And thanks once again for joining us today.
Thanks for inviting me.
Bye.
Bye-bye.
Guys, also do fill the feedback form shared in the chat section, and it will also be used to assign the certificate for this session. It is valid for only 15 minutes and won't be reopened again. Thanks a lot, everyone, for joining us today. Keep an eye on our social media for the next sessions, and forgot to subscribe our channel so that you can get the update for all the workshops coming up ahead. Stay tuned. Do not forget to join tomorrow. Hope to see you in the next session. Stay safe. Take care. Bye bye.